Hello everyone, myself Professor Chavan. We have started the fourth chapter from our 11th Science CBSE board for subject physics. In previous lecture, we have learned about the resolution of the one single vector into its components. How we can resolve any one single resultant vector into its components, and if the components are perpendicular to each other, how can we use the trigonometric rule for finding the magnitude or to find the components of that particular resultant when we know the angle made by that resultant with the any one vector. Okay, so in today's lecture we have to learn about the very important concept in the physics, that is the unit vector. Okay, so what is the unit vector? Why we are calling it as the unit vector? Okay, suppose we have the one vector A. Okay, if this is the vector A, okay, then in this case the length of the vector indicates the magnitude of that vector A, and the direction of the arrow will give us the direction of that vector A. Okay, so from this we will get the length of the vector A will represent its magnitude, and the direction of the arrow will give us the direction. Now suppose we draw one vector here. Okay, we draw one vector here such that it is having a magnitude of a unit. Okay, it is having one unit magnitude. It is having the magnitude as a 1. Okay, it is having magnitude equal to 1 and length equal to 1. Means if we draw one vector in a direction same as per the vector A, okay, and it is having the direction as same as the vector A, and it is having the length equal to 1. Okay, it is having the length equal to 1 unit, then this vector is representing the unit vector for this upper vector A. Okay, this small vector having the magnitude of a 1 unit and direction same as per the vector A will represent the unit vector of that vector A. Okay, suppose we have to apply a force of 15 Newton on any one object. Okay, suppose we have to apply a force of 15 Newton on this box. Okay, the force is 15 Newton. Then in the same direction, if we apply a force of 1 Newton, okay, if we apply a force of 1 Newton, then in this case we come to know that this force is in the same direction as per this previous force, and it is having the magnitude of 1 unit. What is the unit here? It is the Newton. Okay, what is the unit here? It is the Newton. So any quantity, if we have, suppose we have the mass of 5 kg. Okay, we have mass is equal to 5 kg. Then in that case, the kg is the one unit. Okay, kg is the one unit and 5 is the magnitude. Okay, kg is the unit and 5 is the magnitude. So in this case, if we have to find out the unit, then what is the unit vector for this mass? The unit vector will be 1. And what is the unit? It is the 1 kg. So 1 kg is the unit vector for the 5 kg. Okay, 1 kg is the unit vector of the 5 kg. And in this case, the 1 Newton is the unit vector for the 15 Newton. Okay, we can write here the 1 Newton is unit vector of 15 Newton, and here the 1 kg is unit vector of 5 kg. Okay, 1 kg is the unit vector of 5 kg. Now what is the notation of the unit vector? Okay, as we have said here, this small unit, this small vector is representing the unit vector of this vector A. This 1 Newton is the unit vector of the vector 415 Newton. This 1 kg is the unit vector of the 5 kg. Then how we can say that, or how we can give the notation? So the notation for the unit vector is equal to cap. Okay, this cap we have to give. So A cap, it is the unit vector A of A. We have vector A. Then here, if we consider 1 Newton, we have to give a cap. It is the unit vector of 15 Newton. Okay. So like this, we have to represent the unit vector. This A cap will represent the unit vector of A. Okay. And as we know, when we have to give the unit, what we have to do? We have to make the magnitude beside this unit. Okay. So we can say that whenever we have to go for the parent vector, okay, whenever we have to go the parent vector, what is the parent vector between 1 Newton and 15 Newton? It is the 15 Newton. So how we are writing the 15 Newton? 15 Newton is equal to magnitude into the unit. So we can write the 15 Newton as equal to parent is equal to magnitude into unit vector. Okay, magnitude into unit vector. So what is the parent here? It is the 15 Newton. What is the magnitude? It is the 15, and unit vector is 1 Newton. Okay, so combiningly this will give us the unit vector, or we can say here the parent is the vector A, its magnitude is vector mod of the vector A into the unit vector. Okay, so from this the unit vector is equal to the vector itself upon the magnitude of the vector. Okay, so this is the formula for the unit vector, that if we have the any one quantity in terms of the its unit vectors, we can give the unit vector of that quantity as the vector itself upon its magnitude. Okay, we can give the vector itself upon its magnitude. So if we have the any one vector, then we can show, or we can represent the vector in terms of its component, like if it is having the x component, it is having the y component, it is having the z component. Then in that case, to indicate that components, we have to go for some symbolic representation. Okay, we can give the symbolic representation. So how to give the symbolic representation along with the unit vectors? Okay, so if we have the vector A, it is having the component as the x plus y plus z. Then the unit vector along the each particular direction is given by its particular symbol, and that symbols are fixed for that particular direction. That is the I cap along the x, then j cap along the y, and k cap along the z. Okay, we have x cap, x I cap plus y j cap plus z k cap. Okay, suppose we have the any one vector and it is having some component in the x, y and z direction, then we have to represent that component in terms of the x, y, z. Then at that time we have to go for particular symbolic representation, and that representation is given by x I cap for the x direction, the j cap for the y direction, and the k cap for the z direction. Okay, suppose we have one vector like the 6i. Okay, we have the vector 6i. Then if we have only vector 6i, then we have to consider that it is the component along the x direction. Okay, it is the component along x direction. If we have the component as the 3y cap, then 3j cap, then we have to consider, we must have to understand that if here is the j, then what is the j? J is the unit vector for the y component. So this is the component along y direction. Okay, this is the component along the y direction. Suppose if we have to represent this, then how we can represent? Suppose we have one vector p is equal to 6i cap plus 3j cap, then how we can represent this? So for that purpose we have to go for the Cartesian. Okay, and in that case is the 1, 2, 3, 4, 5 and 6. Okay, then it is 3j, so 1, 2, 3. Okay, so if we have to find out the position of that vector p, then just we have to draw one perpendicular from its here. Okay, then the perpendicular from this y component, and this will give you the position of the vector p. Okay, this will give you the position of the vector p. So if we connect this line, this will represent the vector p is equal to 6i cap plus 3j cap. Okay, this position vector will represent the 6i cap plus the 3j cap. So like this way, if we have to represent the any one vector into its component, then we can go by this I, j and k. Remember, I for the x direction, j for the y direction and the k for the z direction. And to find out its magnitude, just we have to take the square root of the square of its components. Okay, so if we have to find out the magnitude as the p, okay, magnitude of the vector p, then just we have to take the square root of the 6 square plus 3 square. So it will give us the 36 plus 9, that is the under root of 45. Okay, so what is the magnitude of the unit vector p? It is the under root of 45 by, okay, it is the magnitude of vector p is the under root of 45. Now if we think about the unit vector, then what is the unit vector? Here it will be nothing but the p cap. Okay, p cap will represent the unit vector. Then in that case the p cap is equal to the vector itself upon the magnitude. Okay, so p cap is given as, we can represent the p cap is equal to 6i cap plus 3j cap upon under root of 45, or we can also write it as 6 by under root of 45 I cap plus 3 by under root of 45 j cap. Okay, 6 by under root of 45 I cap plus 3 by under root of 45 j cap. So like this we can find out the unit vector along any particular vector. Okay, we can find out the unit vector. And why we are going for the unit vector? It is the very basic and very important term in the physics, and that's why we have to study this, the unit vector. Okay, suppose we have the value of the force applied on one boat by its engine and the value of the force applied by its velocity. Then if we go for the addition of this, then it will give us the resultant. Okay, so if we draw this, suppose we have the value of the we have the value here as the, suppose it is the force due to the engine. Okay, force due to the engine, it is 2i minus 2i plus 2j, okay, and force due to the river it is 2i. Then how we can find out the resultant? Just we have to add this, okay. So if we add this, we will get minus 2i plus 2j plus 2i. It will get here 2j. Okay, this is the resultant. Okay, so the vector addition is very simple by using its component along the x, y and z direction. If we represent the vector in terms of its component along the x, y and z direction by using the unit vector, we are having the unit vector along the x, that is the 2 minus 2i. We have the unit vector along the y direction, it is the 2j. We have the unit vector for the force due to the river, it is the 2i. Okay, so in this case minus 2i plus 2j. If we go for the addition here, we can directly go for the addition and these two values will get cancelled, we get the 2j. So if we check it by the graphically, so the force due to the engine it is minus 2i. Suppose we draw this on the one Cartesian, then this is the minus 2i, okay, and this is the 2j. So here will be that vector, okay. So this vector is from minus 2j plus 2 minus 2i plus 2j. It will give us the resultant here. This will be the resultant, and plus 2i, so here will be plus 2i in this direction. Okay, so these two direction will get cancelled and we will get the resultant only along this 2j. Okay, so only this 2j will remain there and this 2j is representing the resultant. Okay, this 2j will represent the resultant. Okay, suppose we have the some values of the vector quantities, like we have the force and we have the velocity. Suppose force is equal to 2i plus 4j and velocity is equal to 3i plus 6j. Then according to the properties of the vector addition, we cannot go for the any operation on these two separate physical quantities, because these two physical quantities are different by their nature. They are not of the same nature. Okay, and what is the requirement for the any operation on the vector? That is the they must have the same nature. Okay, they must have the same nature. Only then we can go for performing the particular operation on that vectors. Okay, we can go for the addition, we can go for the subtraction by using the unit vector concept. Okay, so we can represent the any vector into its xyz component by using the unit vector along that particular directions, but we cannot go for the any operation if the vectors are of different nature. Okay, suppose we have the velocity of a force. Okay, we have the velocity of a velocity of a engine. It is a 2i minus 1j plus 3k. We have the velocity of air. It is 3i plus 4j minus 5k. Then if we have to find out the resultant, then we can go for the direct addition. Okay, because both are the velocities. Okay, so both are the velocities, so we can go for the direct addition. So as vectors have the same nature, we can go for the direct addition here. So it will be minus 2k plus 3j plus I. Okay, it is equal to V resultant. Okay, it is the V resultant. Okay, so if we have to go for the addition of the any physical quantity, then what is important that they must be of the same nature. We cannot add the force into the velocity, we cannot add the displacement into the velocity, or we cannot add the acceleration into the velocity, because only the velocity can be added in the velocity, the displacement can be added only in the displacement. Okay, so accordingly we can go for direct addition or subtraction here, and we can find out the magnitude of that particular resultant. Okay, so how to find the magnitudes? So for that purpose we just have to take the square root of the its magnitude of the all the directions. Okay, so what is the magnitude of the velocity of the engine? It is under root of -2 square plus -1 square plus 3 square. So it is 4 plus 1 plus 9, it is 14 under root of 14. What is the magnitude of the, it is 3 square plus 4 square plus 5 square. So it is 9 plus 16, it is the 25 plus 25, it is under root of 15. What is the magnitude of the resultant? It is the resultant, it is under root of 1 square plus 3 square plus -2 square. Okay, so 1 plus 9 plus 4, it is again under root of 14. Okay, under root of 14. So this is the resultant. Okay, this is the resultant. So if we go for the addition to find out the unit vector along this resultant, then how can we find out the resultant, the unit vector of the resultant? It is given by the VR cap is equal to vector itself, that is how much it is, I cap plus 3j cap minus 2k cap upon magnitude, it is the under root of 14. So unit vector result of the resultant is given by 1 upon under root of 14 I cap plus 3 by under root of 14 j cap minus 2 by under root of 14 k cap. Okay, this is the value of the unit vector along that particular vector, resultant vector. Okay, so in this topic we have learned about the unit vector. Why the unit vector is important? Because if the vector is expressed in terms of its component for its along the particular direction, like the x direction, y direction, z direction, then we can represent the component, that particular vector, by using the I cap, j cap and k cap, which are the unit vectors along the x direction, y direction and z direction respectively. Okay, and when the vectors are represented in that particular directions, then we can add them. Okay, we can add them very easily. It is a very easy operation. We have to go for our regular operation of the addition instead of going for applying any formula, or instead of going for applying any law there. Okay, if we have to know that particular value and we have to apply some laws, then we must have to know for the formulas, like r is equal to under root of a square plus b square plus twice ab cos theta. This formula you have to remember, and in this case you don't have to remember formula. You can directly go for the operation, the regular operation we are applying on that particular vectors for their additions. So we'll get here vector, resultant vector is equal to I cap plus j, 3j cap plus 2k cap. Okay, and its magnitude if we get, and then finally we can find out the unit vector along that particular resultant vector by taking the vector itself upon the magnitude of that particular vector. Okay, so that is the unit vector in the physics.